Question number 18. The concentration of ionized acceptors and donors in a semiconductors are Na, Nd. Acceptors, D means donors, and respectively. Okay. If Na is greater than Nd and Ni is the intrinsic carrier concentration, then the position of the Fermi level with respect to the intrinsic Fermi level depends on. Here is not asking the Fermi level positions. Fermi level depends on which quantity of the following is either Na minus Nd or Na minus Na plus Nd or Ni or Na into Nd by Ni square. So we will see the first. There is a first pure semiconductor. In that there is no addition of Na or Nd. In that case we will see first. If pure semiconductor is there in intrinsic semiconductor, in that the number of electrons is equal to N0. Number of electrons is equal to N0, and number of holes is equal to P0. Now we added if we add the Na donors to the semiconductor, after adding the Nd number of donors, then the semiconductor will become p-type semiconductor. Then the semiconductor will become p-type semiconductor. Now the number of, in this case, number of electrons is equal to N0 plus Nd, and number of holes is equal to P0 only. There is no change. Sorry, this is not P. This is N-type semiconductor. This is, by adding Nd, becomes N-type semiconductor. So number of electrons will increase from N0 to plus Nd. Now after adding, by adding the Nd, now we are adding the Na. After adding the Na number of acceptors, this is not the donors, acceptors, then the number of electrons is equal to same, there is no change, N0 plus Nd as previous case. Number of holes is equal to will change from P0 plus Na, A0 plus Na, plus in our case, in our question, we added the both Na and Nd, both are added. So what is the ratio he added? Na is greater than Nd. Now we will see that. If the first case, we will take a first case. If Na is equal to Nd, we just assume Na is equal to Nd, then number of electrons is equal to number of holes. Both are same. There is no change. Number of electrons is equal to number of holes. Then the semiconductor will becomes intrinsic only. There is no change. Intrinsic only. Then the semiconductor will remain as intrinsic only. If in second case, in the question, Na is greater than Nd, is taken Na is greater than Nd, means number of acceptors greater than Nd, means then number of holes greater than number of electrons, because if Na is greater than, then number of holes is equal to P0 plus Na is greater than N0 plus Nd. Then at that case the semiconductor will become as p-type semiconductor. p-type semiconductor. So here carrier concentration gradient is, or difference of the carrier concentration is Na minus Nd. This is the difference. Effective holes. This is also called effective holes. Effective holes. Effective holes. This effective holes decides the Fermi level of the semiconductor. This decides the Fermi level of the semiconductor. This decides the Fermi level of the semiconductor. So effective carriers, effective holes, Na minus Nd, because Na is greater than Nd. If in case he given Nd greater than Na, then effective electrons is equal Nd minus Na. That will decide the Fermi level of the semiconductor. Now in our case, in our example, Na minus Nd is the effective holes that will decide the Fermi level energy. Option A is correct answer. Option A is the correct answer. Thank you.